Hi, my name is Jeff Brown, and today I'm going to show you how to use knowledge graph software in order to make sense of a complicated call structure. In front of me I have some code for Tidal cycles. Tidal cycles is some open source music software written in Haskell that I really like. And I was reading about the superdirt state function. That does some stuff, and one of the things it does is call the function start voice. So if I want to know what that does, I have to go into my IDE and say, all right, tell me what start voice does, and then, or tell me about start voice, and it'll tell me that's found in stream.hs. So then I can change to stream.hs, and I look at start voice, and that does some stuff, and then that calls onTick. That's one of the things it does. So now I have to read about onTick. Well, onTick is right here, but now what's that do? Well, it uses ticks per cycle. I don't remember what that is, so where am I going to find that? You can see what happens is there's this chain of things to follow. It's not even a chain, it's really a tree. It's this it might not even be a tree, it might have cycles in it. So it's a graph, right? It's this complicated graph of function calls. And I couldn't see it when I was navigating in my editor in my IDE. So, or my REPL, that's really a REPL. Anyway, so I went to Simpson and I put the data in Simpson. So let's go to that right now. So here's the three files that I was looking at. And if I unfold that to two generations, we see the files and some top-level functions in them. These are functions, and this is a data structure that's defined in stream.hs. This is a function that's defined in stream.hs. And these are some functions in stream.hs that I hope are ignorable, right? This is the maybe ignorable category. So all that stuff, I'm hoping I don't have to think about it because it's a lot of stuff. So anyway, that's why I stuffed it into that maybe ignorable category. So now, if I unfold this a little more, we find superdirt state. That's the function that I started looking at. So let's see what's going on there. I'm going to visit that now. So I go to superdirt. If we see superdirt state is listed at the bottom of the screen, so that says that's what we're looking at. And so we see that superdirt state calls start voice. Start voice calls onTick. Start voice also calls closed tick. onTick uses the backend data structure. Closed tick calls these three functions. If I expand that even further, we see that there's a lot of stuff going on underneath run client. Mostly this looks like a tree, right? Most of these things most of these functions are only called by one other function. And we can see that over here. This first column of numbers lists the parents of the items to their left. So start server, for instance, has one parent and two children. Start server's children are server app and slave, and start server's single parent is connect client. But some things have more than one parent, right? If we look at run client, that has two parents. We can see one of them, clocked tick, but we can't see the other one right now. So, and that's because the view that we're looking at is defined by superdirt state. It's all the descendants of superdirt state. So now let's visit run client. I visited run client, we see run client at the bottom of the screen. So now I'm looking at all the descendants of run client. So run client calls connect client, that calls client app and start server, etc. But now I can look backwards, right? So remember, run client had these two parents. If I look backwards, I see the two parents, right? It's called by clocked tick, and run client is also called by CPS utils prime. Now if I unfold that a little farther, I see, okay, clocked tick must be a top-level function because one of its parents is network.hs. Clocked tick is called by start voice. Well, where's start voice? If I open it up to three generations, I see that start voice, oops, what happened? Sorry, I pressed forward, so I was looking forward for a second. Now I'm looking backwards again. So, clock tick is called by start voice. Start voice is a top-level function of stream.hs, but start voice is nonetheless called by a function. It's called by superdirt state. So if I unfold a little more, I see that superdirt state is called by superdirt status. Anyway, you see the point is you can make sense of this. Like, that would have been really hard to do, navigating all those things in in Emacs. And Emacs is wonderful software, but still, you need a graph. You need something that reifies your data, because your data is a graph, so you need something that understands graphs. And Semantic Synchrony does that. Semantic Synchrony does all sorts of other stuff too. And if you want to read about it, you can. We have this website, github.com/synchrony/Simpson. That stands for Semantic Synchrony. Semantic Synchrony. So that's the website. Semantic Synchrony is the software. Knowledge graphs is the more general concept. If you find other software that does knowledge graphs better than Semantic Synchrony, please tell me about it because I want to know. And my name's Jeff Brown. Thanks for watching.